Good evening and welcome to WeatherBrains. This is the pre-show, and welcome to our television viewers watching locally. We are actually going to be airing the pre-show this week, which we normally don't do. This is for Christmas evening, December 25th. And for those that don't know, the pre-show, it's the magical time of the program where we share boring personal stories, humorous anecdotes, and we say outrageous things. And Brian and Bill, just so you'll know that we are on television now. The pre-show will be on this week, so be careful what you say, Brian.
Gee, thanks.
No, typically,
do I say things you don't care for?
Well, I'm just saying that sometimes you might say things on the pre-show that you know would not be on television, and I'm just saying, it's. I don't know what I'm saying. I'm saying this is Christmas, and we hope you and your family had a Merry Christmas today, and we're going to let you in on a little secret. A little secret. All right. Are you ready?
It's a big secret.
Well, we're pre-recording this program. So that's
Fake
the reason.
news.
That's the reason that we are the television will just roll it, and what they're going to do on television, they'll take it right as this video begins. So we are on television now. So that's the deal. So, but hope you had a Merry Christmas, and hope Santa Claus came to see you and all that kind of good stuff.
You got a new shirt.
Yeah, I met my third grade pals at Shades Mountain Elementary School gave me this for Christmas.
Meteorologist almost doesn't fit across the.
I know it's like I need to be a wide body here. So,
I didn't say that.
Well, I know what you're trying to say. So, I also left my fancy little things like Bill Murray has, the little ear pods. So I'm having my obnoxious wires back here. I'm out of sync because this is a Wednesday night special. I'm just totally out of sync here. So.
Yeah, y'all missed it here in St. Louis. I hear these sirens, outside my window on the interstate, and I hear one, and I hear two, and you get up to six, and it's like, that's a lot of sirens. And I look, and there's like 40 police cars, and I throw on the TV and look real quick, and this high-speed chase, this carjacking went right outside my hotel, and they followed them in the helicopter. It was on Murphy Station, James, KMOV.
Wow.
And
wow.
They ended up finally crashed.
Nothing beats a good car chase. Yeah, nothing beats a good car chase live on television.
I was like, wow, it's right outside my window. This is pretty cool.
Well, you should have just gone out there and chased the guy down and pulled him out of the car and
had him on WeatherBrains.
Make a citizen's arrest.
Yeah, I was thinking that, it would have been, just pull your car out in front of him and make him crash and, get out and just punch him. But anyway.
So
I was looking at your pick of the week there, Mr. Murray. I don't think I can afford to go.
Is it expensive?
The top tier ticket's $975. Yes.
No way. That's a lot.
That's a lot.
Oh, that's the top tier or the entry level ticket? That's what I care
about. The top. That's the top. They always start at the top and work your way down. I mean,
well, yeah, you do, Mr. iPhone X. You do that things that way.
Yeah,
you go for the champagne and caviar dreams, Brian.
Yeah, the simple ticket. I love the title. The simple ticket is $100.
Okay, well, I can probably afford that.
Yeah, I haven't scrolled down far enough to find out what it gets you, though.
Well, probably access to every film. That would be fun, and it came across my interest screen because Dr. Pat Market at Mizzou told me about it, and the visual artist that's putting everything together is using all weather illusions for it. So that was kind of cool. I'm hoping my internet will hold together. I wanted to use my fancy new MiFi, but somehow the battery ran out today, and this sucker takes a long time to charge. So when I pulled it out to use it, I was like, well, this is not good. So anyway.
We'll see. Kim's new name is June. Is that right? Kim, did you see that email?
Yeah, people screw up my last name all the time.
Hard to mess up Kim.
Right. But you know how you get June. I just learned this because I thought, how did it even do this? You get that by transposing, going left one key on the keyboard. You get June. I mean, he's like he just didn't even look up to see what he's typing.
I
It's
saw
pretty
that and
special.
thought, wow, she now she's changing her first name, so we got to learn this whole. We got June Cloco McLean.
June
It does
Cloco
get-
McLean.
It has a good little ring to it, but no,
But how could they take a
something.
3-letter word and make it a 4-letter word?
no,
With just
Jun is what they type.
Jun.
Jun,
Oh, okay.
like June.
Jun. Yes. Jun.
Jun.
Yeah.
Yes.
Yeah. I've also shifted ethnic backgrounds slightly.
Yeah.
I don't know.
Did you
I
have
just-
kimchi for dinner tonight, Kim? Kim Yoon McLean.
Yeah, Kim, by the way, congratulations. You now have the longest name in the picks of the week.
Oh, that's great.
You're
Thank you.
2 characters ahead of Aubrey Urbanowitz.
Oh, wow. That's an accomplishment.
You know, that's an accomplishment. Her last name is truly amazing.
Hey, Pam, can you hear us okay? If you can, we can get started because we're on television now. You hear us okay?
I can hear you. Can you hear me?
Loud and clear.
Okay.
So let's just do this thing here.
Okay. Do it.
Kim has some fancy. I mean, Pam has some fancy computer, James, that focuses in and out on her. It's like she's got a live cameraman there.
About to say, well, that is an ultimate close-up right there. I mean, wow, that is tight. I mean,
Yeah, we're right in your face, Pam. There we go.
Lisa's not like that guy who did his iPhone and kept shoving it up to his ear, and we kept looking at his ear hair.
that was nice.
I need to get wireless earbuds so I can see I'm kind of pancaked on here. But, pink is good.
I've got the white one, so it's all good. All right, so here we go. Let's hit the record buttons so I don't forget. And here we go in 5, 4, 3, 2, 1. This is WeatherBrains episode number 623. It's the Christmas night edition. This is for December 25th, 2017. Hopefully you and your family had a very merry, meaningful Christmas. Santa Claus came to visit. Brian Peters, I know what Santa Claus brought you. You got that thing up at Huntsville when I was with you.
Yes, that's my
Fancy
present
iPhone.
for this year. So
Yeah.
spend all my Christmas money in one spot.
Yeah. So, Brian, should we let him in on the secret here? I think we
No.
need to.
Absolutely not.
We are actually pre-recording this because, it's Christmas and most of us wanted to be home with our family. So we're actually recording this back on December the 20th. So that's our little secret. Don't tell anybody.
Actually,
real
I wanted to be home with your family.
Well, come on, Kevin.
The real secret is it's December 20th, 2016.
Yeah. Wow. So, Kevin, Merry Christmas to you and your family.
And to you guys.
Are you working today?
I'm working on the day we are recording. I will not be working on the day that it is released.
Yes, I for years and years and years, I've always worked Thanksgiving. I have worked every Thanksgiving since 1973.
Wow.
But in my older age, I have been off, generally speaking, Christmas week. So it's kind of a trade-off deal. So, Kim Cloco, are you working December 25th? Or are you able to take the day off?
I'm able to take the day off, fortunately. So I will actually be home in Indiana for Christmas. So that's always fun for me because Indiana is real winter. Oklahoma doesn't have what I consider to be real winter, being from the Midwest. So I'll be up by Lake Michigan. Very excited.
So I got a note from Dan McCarthy. I don't know if you know Dan, Kim. He's the
Oh, yeah.
MIC at Indianapolis, and he wants me to come up and speak to a little symposium up there. So I will be in Indiana in March, which will be a ton of fun.
That's going to be great.
Yeah.
Uh-oh. Bill, you and I need to get ready.
Yeah.
It's going to be
road
the
trip,
biggest
road trip.
severe weather outbreak
Oh,
ever.
exactly. Yeah. What am
the
I
super
thinking?
outbreak of all outbreaks on March, I think it's March
Lord.
17th. So just write it down. It's going to
Yeah,
happen.
mark it down.
In fact,
Yep.
I can tell you it's going to be funky because that week I've got the function in Indiana, and then the next week I'm speaking at the University of Georgia. So somewhere in there, something's just going to happen.
Too
But,
many possibilities to count.
Yep. But Bill Murray, let's go. Bring in our guests.
Yeah, James. Tonight's guest, WeatherBrain, is the program manager for Warren on Forecast. She's also the acting division chief for FRDD, and I'll let her explain what that is. She was a PCASE winner in 2009. I'll let her explain what that was, too. Dr. Pam Heintzelman, welcome back to WeatherBrains.
Hi, thank you. It's a pleasure to be here.
So you did the NWA webinar series today, too, which is one of those reasons why NWA, that's our hashtag NWA members are running this week. Do you have any voice left?
I do. I've had some time to rest it since I did that, so should be good.
Well, good. So explain what PCASE is real quick. That was a really prestigious award that you won.
Yeah, so PCASE is the Presidential Early Career Award for scientists and engineers, and it's given out to 100 scientists each year by the President of the United States. And it's very exciting just because it's a way to recognize research that is very relevant to our country, and also recognizes scientists who are making significant contributions and show potential for leadership.
And that was in 2009?
2009.
Wow, 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 wow. I love your cool camera that zooms in and out. This is just so neat. None of us have that, Pam, so we're all fascinated by that. But go back to the beginning. How did you get interested in weather, Pam?
Well, I've been interested in weather for a long time. And my mom tells me that when I was in kindergarten, I was actually afraid of raindrops. And so I used to try to just brush them off with my raincoat, didn't like them too much. But then as I grew older, I became fascinated with thunderstorms and, all the things that come with thunderstorms, the winds, watching the trees being blown over, wondering if they're going to snap or if they're going to make it. And then I had this wonderful class when I was in the 8th grade. And that was my first real class in weather. And I've been hooked ever since I took that course.
So you should have taken the advice of Donald Fagen and his great song, one of my favorites, Walk Between the Raindrops, Pam.
Yeah, there you go.
If you could just walk between the raindrops. So where did you grow up, Pam?
I grew up in Maryland, and so that's my home state. And I always like to go back because I love crab cakes. And so anytime I can get a hold of a true Maryland crab cake, I'm a very happy woman.
Well, there is something to be said about blue crabs out of the Chesapeake. That's and it's amazing to me that they've got that back to a sustainable fishery again. It seems from what I hear. I don't know that that's absolutely true, but I saw a show on it a few weeks ago, and that makes me happy because I love a blue crab. My first experience, I had a ticket I had to burn on Southwest Airlines, and I'd never had, a true Maryland steamed crab. So I used this ticket just to fly to Baltimore and turn around, fly home like in 1997, and just drove down to a restaurant and got the crabs. Well, it's funny because, when they ask you what size, they say, what size do you want? And I have no idea. They say, and back then they're probably more expensive now, but they said, do you want the 60s, the 70s, or the 80s? And I had no idea what that meant. What size was a 60 and a 70 and an 80? And you know what that means, Pam. It means how much they cost per dozen.
Yeah, that's right. It can also mean what kind of music do you like to listen to?
Well, that's true. Those are the first 3 channels on my XM are the 60s, the 70s,
that's
and
right.
80s. So that's exactly right. So Pam, we've got you here tonight. But when we talked to you before, you were focused on phased array, and we'll talk about that in a minute too. But now Warren on Forecast is your focus. So first, start off. Tell us what it is.
Okay, so Warren on Forecast is an initiative at the National Severe Storms Laboratory in which we're looking at the ability to use high resolution, frequently updating on-demand forecasts. Okay, so we're talking about putting together a forecast over a domain where you may have a high need for frequent weather short-term forecasts. So like where, for example, where you have an enhanced risk for severe weather in the springtime. And looking at producing short-term forecasts that would provide information about the probability of various types of severe weather and also the intensity of those severe weather attributes.
And so how many parameters are you tracking, or that sort of thing, Pam? What are you looking at, and what sort of grid spacing are you talking about?
Yeah, so there are a number of attributes that we look at. One of the key ones that seems to be really useful is updraft helicity. And so we like to look at that both mid-levels and then also closer to the ground. And we watch the development of that, say, over a 3-hour period. So you may see this swath of very well-defined updraft helicity, for example, associated with what may be a supercell. And so that kind of information can help you discern the storm mode that may occur and how intense the updraft and rotation associated with it may be. But the grid spacing that we're looking at with that system right now is a 3-kilometer grid spacing. But our ultimate goal is a 1-kilometer grid spacing.
And so what models are giving input? What other observationals are giving input directly to the system right now?
Okay, so we are using the ARW community model, or WRF. It's also known as ARW WRF. And what we do is we first run a data assimilation ensemble. So we assimilate a 36-member ensemble, and that includes data from weather radars, both reflectivity and radial velocity. It includes GOES satellite data. It includes surface observations, things like that. And so those data get cycled every 15 minutes. We have an analysis. And then from that analysis, we will run an 18-member ensemble forecast. And currently, we do that at the top and the bottom of each hour, out 3 hours at the top of the hour and an hour and a half at the bottom of the hour.
And so that's giving you probabilities then basically on all those grids?
Right, so from the ensemble members, from the 18 ensemble members, we can then look for things like exceedance values for various parameters, whether it's updraft helicity or reflectivity at a certain threshold, or an amount of accumulated rainfall over a period of time. And so we can look at the number of members over the period that are above that threshold, and that would give us a probability associated with that. But we also like to look at percentile values, because those can give you a feeling for kind of like what the minimum threat may be, and also what a reasonable maximum may be associated with that parameter.
Pam, and this will actually end up being for Kim as well. You've said a couple times, and I've heard this over the last couple of years, the increasing use of the term and the usage or planned usage of probabilities. And part of my role in this program is to cause trouble. So I want to ask this question, but it's genuinely an interest of mine. I have heard probabilities, and I get it, and I understand it, and I think I agree with it. I have not heard anybody explain whether the general public understands those, and will they be a benefit or a burden to some people. For Pam first, and then Kim can come and punch me in the nose.
Okay, so based on the research that I've seen, a lot of it's been done by Susan Jocelyn, and her research indicates that perhaps the public understands probabilities better than we think we do. At least that's been my takeaway from some of the research that she's done. And then I'll hand it over to Kim.
Yeah, well, and just to answer that part or come back from a broadcaster standpoint, one of the things that I felt like I have always heard is that, and I'm making up these percentages, but when we talk about probability of precipitation, half of the audience thinks it's a probability, and the other half thinks that it is aerial coverage, and that's kind of the foundation of my concern.
Yeah, there are a number of different. She's done work on that too, and there are a number of different interpretations to that. You're absolutely correct. But Kim, why don't you go ahead and handle this one?
Yeah, this is a really good and important question. I think something that's of interest to both Pam and I, working on some of these issues, is making sure that we put something out that can be useful to the general public, but also, frankly, to forecasters. And this is going to be a question I'll ask you about, Pam, in a second. But I do want to address what just raised, and what the class of challenge that you just brought up is to psychologists known as the reference class problem. So what people aren't understanding there isn't so much that they can't interpret the number itself. It's not that the number is problematic. It's that they don't know what the number means, like what it refers to. So there could be different interpretations of, it's a 70% chance of what? It's that of what that people get confused about. So there's some work that's been done in psychology by Susan Jocelyn in particular for weather and people understanding probabilities that looks at the numbers and how you can display the numbers in ways that people understand more easily. So there are some people who can understand visual representations, box plots, different kinds of graphics more easily than number formats. There are also some kinds of number formats you can present, like odds. There's a 1 in 10 chance, of something happening is actually more cognitively efficient than a 10% chance. And people tend to make fewer judgment errors when they're given something like that. So you can work on the number part, or you can work on that reference class part. To me, I'm actually very concerned as we're moving ahead with the probabilistic information and trying to give a whole lot more than we're giving today about that reference class part. And I'm concerned that we already in the public space have a couple of different reference classes floating around for severe weather days. You have the Weather Channel's Torcon, which is like a sort of a 1 to 10 scale of risk. At the same time, the SPC risk is based on probabilities that are really just, they're mathematically equivalent. They're just talking about the probability over a smaller domain. So the SPC is the probability of incurring, say, a tornado over 25 miles, within 25 miles of a point. The Weather Channel, I'm convinced it's just within 50 miles of a point. So they can convert the probabilities that go to around 50% is the highest that SPC goes. They can go maybe just a little bit higher, but they can, if you double the domain, then you can get up to 100%. So it's the exact same thing, but what you get on the back end is a totally different number. So people might see that as inconsistent, and they might think, oh, these forecasts are disagreeing with one another. But they just don't understand. And this is complicated. I mean, I'm sure it's complicated for everyone listening to wrap their minds around what I just said and do the math and do that conversion. So I think, that's just one small element of the kinds of things that we're trying to convey today. If we're going to open the door to communicating probabilistically, we're going to open Pandora's box of all of those challenges. And so this is where I want to turn it back to Pam. Pam and I actually have started doing a small research project together on forecasters' understanding of probability, and especially with the kinds of tools that you're creating. Can you tell us a little bit more about that? Your interest in that area expands also beyond just our project, but you've done some work with forecasters for some time.
Yes, that's correct. Yes. So yeah, our project is an interesting one. As we're developing these probabilistic forecasts, forward-on forecasts and percentiles, and thinking of different ways of expressing this forecast information, we think it's very important that we understand how those ways of expressing the forecast are being interpreted, not only by the forecaster, because of course that's the person who is ultimately going to use the information, and we want to make sure that it's usable and also understand perhaps what kind of training may need to take place, but also the model developer themselves. Do they understand these concepts, and how does their understanding match or differ from that of the user, such as the forecaster? So our ultimate goal is to make sure that ideally we're on the same page, and that the forecasts that we put out there are usable and meaningful to the forecaster.
Well, I appreciate the discussion of the difference between the number and the what is it part. That was helpful. are we going to get to a point where, like, especially in the springtime, we've got a 30% chance of rain and a 70% chance of increased updraft helicity in a given area, and putting those things out, does that cause confusion at the same time?
Would you ever say on air, you know, talking about updraft helicity? I'm not sure that I mean, some of this is not going to go to the public, I hope.
Well, part of my next question, please go ahead.
No, I mean, this is going to be the discretion of people like you, who are broadcasters and are in a position to transmit this information to wider publics. Some of this is going to be your interpretation, and this is one of the reasons why it's so incredibly important for us to bring in broadcasters as we're developing these technologies. And that's started to happen, but you do currently in your forecasts, you give people probabilities of precipitation over, you know, the next days and weeks, well, days/week ahead. And you also have on severe weather days, you'll offer probabilities of incurring different kinds of hazards. So people are encountering these different reference classes of probability in your forecasts now. What you might just encounter is in your coverage, in real time, you'll have probability that may be updating. This is the kind of stuff that Pam is developing and others are developing. And you can actually offer, hey, the probability of a storm in this environment producing a tornado has actually just gone up. What will people do with that? That's a question that we're still trying to do research to address.
Yeah, and that actually leads right into my next question. And don't get me wrong, like I said, I'm paid to be the troublemaker here. I get all that stuff, and I like it. But we're in the world now where that stuff gets out and gets misinterpreted, particularly on social media. And you kind of alluded to that by saying, well, this information is for the broadcasters or some particular group, but can we do that anymore? This stuff's going to get out. And I was talking with somebody the other day and was sort of referencing something we've talked about on this show in previous weeks, where we're rapidly heading toward an hour or even a 90-minute tornado forecast. And I said, well, does that scare you? And this person said, yes, it terrifies me. So having that information is one thing, but managing it and then managing it as it goes out in an open world of information is additionally problematic, I think. But we can't stop it, can we?
And so a big part of that is facets, right, Pam? And what you're forming now eventually becomes the backbone for that program.
Yeah, that's right. Yeah, facets is forecasting a continuum of environmental threats, and the idea is to make sure that the information that's flowing, from larger scales, down to what might be like the watch scale to an outlook scale. I'm talking about short-term outlooks when I say that, to a warning scale, that there is continuity between those scales and the forecast information that is being presented to the public.
Do you restrict then who gets that information?
Well, I think that when we talk about information sharing, there's really a communities or, a variety of communities that are out there. And so, the information that goes out to those communities may be packaged, in a different way. It wouldn't necessarily, I wouldn't necessarily, put out in a National Weather Service forecast, helicity plots and reflectivity, probabilities and things like that. You would, package that in such a way that is meaningful, say to a broadcast audience, but which may not be, all the way out to an hour. Okay. Mm-hmm. But if you're providing information, to a hospital user, someone who's going to need to move a lot of people in a location like that, or a stadium, then the need there is going to be different. And so I think that part of the beauty in having probabilistic information is the ability to provide the user with what they need based on what their needs are.
Mm-hmm. But will the kid in his parents' basement in his pajamas have access to that information? And then an even trickier one is, we see I guess what you would assume to be responsible television weather people putting out the 384-hour GFS forecast and calling it gospel on social media. And so I guess the question is, again, who gets that? Who gets access to that stuff? And then how do you control who does, or can you? And then once they start becoming irresponsible with it, then that's a deeper problem, I think, too.
Well, I mean, I think now, you could say that people have access to data that they may or may not understand. So, for example, anyone can get a hold of dual polarization weather radar data. And, could that be harmful to them based on, some of the products that are put out by GR2 analysts? I know they make decisions, based on that, which, isn't coming perhaps directly through, what's seen as an authority, but the data is out there.
Sure. Yeah, I appreciate it. It's a hard one.
Yeah,
Yeah, it really is.
It is hard.
So, Pam, how far away are we from, this data becoming part of facets, and how far away are we from facets becoming a reality?
That's a good question. So we've been looking at timelines right now within the reality of where we are in the development of Ornon forecast right now, as well as where EMC is in its development. And so taking both of those and also high performance computing resources in mind, what we're targeting for a kind of a version 1 or a starter version, if you will, of Ornon forecast is around FY22. And so between now and then, of course, a lot of our focus is going to be on giving a lot of testing time to Ornon forecast in a number of different applications. And this past year was the first year that we really kind of put it out there, both in terms of use in the test bed, direct use of the probabilistic and percentile information produced by the model, as well as within the Norman Weather Forecast Office.
So who were the subjects in those tests, Pam?
Okay, so in the hazardous weather test bed, we had the spring forecast experiment, and that's run jointly by Adam Clark of NSSL and Israel Jarak of the Storm Prediction Center. And there, the majority of people who come are from the weather research community. And a smaller portion of them are forecasters from National Weather Service. And there are also some folks who come from other countries, and some students and postdocs as well. But the majority are from the research community.
So I heard a term thrown around today called pseudo-operational testing. What does that mean, Pam?
Okay, so pseudo is like, you try to make it real, but it's not 100% real, right? And so what is done in that test bed is that they try to go through a forecast day, similar to what the SPC would do in the real world, but they aren't really issuing forecasts. And they start from kind of like the larger, scale in the day, and then go to shorter and shorter time scales. And so within that, later in the afternoon, we were looking at the experimental production of 1 hour severe weather outlooks. And those were probabilistic, essentially showing probabilistic areas and what the probabilities within specified areas that would be drawn on a map were for severe weather.
And so they saw these things in real time. Did you get any interesting input that from the community that you were testing with that helps you shape what you were doing?
Yes, it was very interesting because in that program you have a community of people there, but the driver is this past year and in several years before this has been Dave Imey, who is now a retired SPC forecaster, and a really good one. And so he got to work with this data coming in over our web interface every day for about 5 weeks. And so we had folks down there, observing him who are from our program and keeping notes on what types of products he was using and what his thoughts were on that. And it was interesting to learn about the evolution of using those products because initially, perhaps there was some resistance to using things that were not in the usual toolbox, such as percentile products. But as the exposure happened, then it really became something that this forecaster enjoyed using. So it was interesting just to watch what the evolution of use for a forecaster looked like. And we also have a full set of those outlooks that we're looking at the verification numbers for compared to, say, a practically perfect forecast. What did the forecasts look like that were based on the Warn-On forecast output, as well as some observations that would normally have available.
So I suppose, and I'll ask Pam and Kim here, there's a difference between a probabilistic forecast and a percentile forecast?
So they were putting out probabilistic forecasts, so it was the probability of severe weather as a whole over a forecast area. That was the focus for the day. The percentile values help to provide information about intensity. So for example, you could have a very high probability event, but perhaps low end intensity based on the percentile values, or you could have a very low probability event with a very high end percentile values. And so you can have a whole mix, of probabilities, and then what does the intensity look like that's reasonable, like a max or a min for the day.
So Pam, when did you first get your hands on real-time operational use of Warn-On forecasts? And give us some case studies. I know there have to be some exciting examples where you saw the promise of what it could mean for us in the future.
Okay. So in the test bed, one of the cases that really stood out for this year was a wind event that occurred over Iowa, and the outlook for that ended up evolving from the first outlook, kind of like this circle, some rings in it, and then the next outlook following that with the next forecast that was put out an hour later from Warn-On forecast, they were able to discern two specific areas of severe weather separated from each other. And when you look at the practically perfect forecast, the observations are directly within those two areas, and they're actually separated. So that was a very encouraging result from the pseudo forecast environment. Within the real forecast environment in the Norman WFO, the success story that they've talked with us a lot, and they've also publicized, was 16 May of 2017. And that was a day in which there was an EF2 tornado that came through Elk City, Oklahoma. And they were looking at the forecast in real time, several hours ahead of that event. And based on the updraft helicity tracks and other information they had available, they decided to put out an advisory for potential tornado warnings to come within that area. And it turned out that did happen within the area of concern. And they were very pleased to have that forecast information that followed, from the watch that had been issued, and then before warnings came out, that they, had this forecast information rapidly updating and available in that time frame.
So that's sort of like the MCD is between the outlook and the watch. That's an interesting product for sure.
Yes.
You mentioned a term, and I think you talked about it for a second, and I kind of missed what the definition was. What's a practically perfect forecast, Pam?
So a practically perfect forecast is one that's based on where the storm reports fall, what the kind of like the best distributions of probabilities would look like relative to that distribution.
That makes sense. So, and I guess, from what you're describing, the SPC has to be really interested in this data because it's probably going to become important to them as they change their outlook structure temporally, I suppose.
Yes, yeah, it is. And it's exciting because last year we were looking at this. They have two desks in which we work at. One's called the Innovations Desk, which is run more so by NSSL. The other side is the SBC desk. And last year we were running experimentally only with the Innovation Desk with these 1 hour outlooks. And in 2018, they'll be using the Word on Forecast output at both desks with the SBC desk looking at its utility for 4 hour tornado outlooks. So looking more so at specific weather hazards, and they will be using it within their operational environment as a tool for that same type of experimental forecast. So it's very exciting to know that they're interested in getting their feet wet in the utility along that line.
I'll make sure I ask this while Kevin's awake because I tended to drop this question when he was asking his questions before. But is any of this data available to us now as operational forecasters? Can we access any of this data right now? Obviously, that's the Pandora's box question for Kevin.
Yes.
But I'm interested to know that.
It's accessible. What you do with it, it's out of my hands.
No disclaimers there, huh?
No, we have a website that we're currently using to display, all the different products we have available for environment, for hail, for rainfall, for rotation, and we also have verification information. And so that is available for anyone actually to look at prior cases we have on there. We have prior cases from both 2016 and 2017 that a person can look at, and then when we're running in real time, wherever the domain is placed, those forecasts are available as they come out on that web page, and they are freely available. There's no password, protection anymore on that page, and you can also look at individual members. So if someone wanted to look at the forecast from each member, that type of display is available as well.
What's his website here? Hang on. What's the URL here?
So the best way to get to it is to go to the National Severe Storms page. So it's www.nssl.noaa.gov. And then after that, we have /projects. And of course, the project we're talking about here is Word on Forecast. So that would be /WOF. Followed by /NEWS-E or News-E, which is the NSSL experimental Word on Forecast system for ensembles.
I think that's the biggest stretch of an acronym yet.
Wow.
Right there.
So it's projects, WOF, and then NEWSE.
Yes. There's a dash between the S and the E.
Oh, okay. There we go.
Yeah.
So let's try that and let's see if this works. And yes. Ooh, okay. That'll be some late night reading material.
Well, near the bottom, there's a link to actually go to the page, and it may still say it's restricted, but it's not. It's not restricted.
It says restricted access with this big lot thing by it.
Yeah, it's not though.
Okay. That's to keep the Facebook users out.
This is like I feel like I've just won a treasure hunt here. This is fantastic. So
that was worth the price of admission right there, wasn't it, James?
Yeah, exactly. All the WeatherBrains creepers will be on this thing too. So hopefully we're not going to bog the server down.
Yeah, that'll be great. We'll bring it down during an outbreak. Wonderful. So you're testing this new Z and the flash flood and intense rainfall experiment this year. Pam, talk about that for a second.
Yeah, we're also looking at the rainfall application, which we're also very excited about. So it'll be running as part of the FAIR experiment, as you said, and also being used. We're very focused on the MetWatch desk within the center. And so we intend to have them, they're interested in using it in real time, just as the Norman WFO has and as the Storm Prediction Center will be as well this coming season.
Yeah, we needed in Birmingham this morning with the heavy rain we experienced there in a very short period of time. Because keep all the people out of the overpasses or the underpasses, I guess, is our big thing. So anyway, I heard about the two case examples that you talked about, the Elk City example and the Iowa wind example. That's really cool. You know, you mentioned fiscal year 22, Pam. Take us through the research to operations process, what you'll be doing over the next 4 or 5 years.
Okay. So a big part of what we'll be doing next is just running the model as much as we can. And the reason we need to do that is that we need to understand its strengths and limitations insofar as, you know, different weather modes are concerned. You know, does the model tend to perform better, and in which ways better? You know, if you have a supercell type storm, and what about, you know, supercell very strongly and clearly forced versus, you know, more marginally forced, or squall lines, you know, downbursts, you know, isolated storms. So we really need to run the model hard so that we can understand those strengths and limitations. I think that's always very important if you're going to transfer technology, you know, to understand what those are and improve the model to the best that you can prior to a transition to operations. And running the model over several seasons will also allow us to eventually calibrate the output. And, you know, of course, you want to do that kind of near the end, because once you calibrate, you don't want to do it again for a while. So we'll be looking at, you know, verification statistics along with that, because we know that we need to show, you know, very strong performance in order for the system to eventually be transitioned to operations. The testing we're doing, the test bed, is also, you know, another component of that. So the forecast community, you know, needs to agree that this is something important, you know, on top of, you know, showing some good evidence for the EMC to want to transition this to operations. But another piece of that is also for EMC to have a parent model available for us that's a convective allowing model, that's an ensemble that can provide the background and initial conditions that are required for us to run. And currently we've been running our model in coordination with GSD, the global, excuse me, GSD at Esrol, you know, in Boulder, and their experimental ensemble, the HER-E ensemble, has been running as our background, and we're dependent on having a model like that available in order to transition to operations. And 2020 is a year, if you look at some of the, like the milestone diagrams for EMC, that's a year in which they're going to be deciding whether or not, you know, HER-E, the ensemble, may actually be transitioned to operations, and how that will be determined in part by how far along the FE3 type of CAM has developed to that point. Because you may have heard that the National Weather Service is moving toward a unified modeling system and attempting to use the FE3 core, not only at the global scale, but bringing that down to the convective allowing scale. And so whatever decision, you know, is made at that point based on the evidence of performance with those systems will determine what the background model will be for us, and will then, of course, also impact our readiness and how quickly we could get Warn on Forecast out there.
So James Fan, I think we just pegged the WeatherBrains brains meter there. I think that is a record for this show. That section right there.
So let me ask you all this. You know, my concern is that the private sector, they're about to go their own way. I can see this train coming. I can see it coming. And you talked about Torcon. Kim, as I understand it, they claim this thing is proprietary. It's their own proprietary index based on some secret, you know, formula that they've got, and it's better than the SPC.
It's just it's X times 2.
and I just see, and you got local stations where you guys are in Oklahoma City issuing their own warnings. I see these push notifications, blah, blah, blah is issuing their own warning. What if, with NSSL and SPC and everybody within NOAA, they develop these amazing warning products and with facets and everything, but what if nobody uses them outside of NOAA? Do you guys worry about that?
I don't know, Pam, do you want to take a crack at that? I'm not sure if that's, I mean, I also have, I have some early thoughts based on some of the work we've done in the test bed with end users, including broadcasters, emergency managers. Everyone always leaves from the week saying, oh my gosh, when can I have this? I already miss it. And it's been gone from my hands for 5 minutes. So I don't know, Pam, if that seems to jive with your experience too, but with some of our end user groups, that's definitely been ours.
Yeah, that's been our experience working with forecasters with rapid scan phased array radar data. They got used to it really fast, and they realized that they had to go back to their home offices and use the more legacy update times, and sometimes that was a difficult transition.
Well, again, my point that I'm trying to make is the fact that I believe that the Weather Service should be the ones that issue the watches and the warnings, and we should be the ones that disseminate those products. And we do it all in unique ways, but we all communicate the same message. But I see that train coming, and I hope it doesn't come to that. But facets, if it comes operational in 5 years, in what, 22. I just don't know what the state of the weather enterprise will be at that point. But there's so much pressure on these broadcasters to keep pushing the envelope, to do a 15-day forecast, to issue your own warnings. And we're all better than the Weather Service. We know better than everybody else. So I'm hoping along the way that we can somehow come to an agreement that we kind of are on the same page. And I hope the Weather Channel doesn't go from Torcon to do their own warnings and watches next. And again, I see so many local TV station groups trying to do this. And to me, I'm excited about these developments that you're talking about, Pam. I think it's marvelous. And there's some brilliant people there in Norman that are working on this, including you and Kim. And I just hope we stay on the same page. I don't know. We'll see. I'm just greatly concerned.
Well, it is going to be interesting to see what happens. And this has actually been one of our great challenges on the warning timescale. And also on the watch timescale, how we think about the kinds of products we're creating and how they should relate to the watch warning system. So some of our early attempts over the last couple of years to do have a something at the scale of a warning, but going out an hour, having probabilities for severe convective weather going out an hour ahead of time. Some of the automated plumes would drop out a warning at a certain probability level, and that a whole segment of end users didn't like that. It turns out, no matter what we've done to try to comport, at what should it be a probability level? Should it be a distance? What should it be where the warning happens? It's not satisfactory to everybody. And it's probably because warnings aren't just issued when you hit a certain hazard probability level. They're probably not, they're multidimensional. They also relate to all kinds of things forecasters are thinking about. Even though we might assume that it's just, hazard's really likely, I'll issue a warning. It's also about things like population that's going to be affected. If it's heading toward a city, a forecaster might be more likely to pull the trigger earlier. And emergency managers also think about this in a very different way. So when you're talking about who will have what kinds of watches, warnings, how will this information be understood? I think that is something that's going to be a challenge. We might see cases where we're putting out this probabilistic information and the probabilities maybe look like they're going to be quite high, but forecasters aren't issuing warnings. And that may open a door for credibility challenges, from broadcasters who are looking at this saying to their audiences, hey, look, there's this high probability storm heading for this town, but there's not a warning, question marks. They already sort of do this, right? They already do this with their automated algorithms that show these little, velocity couplets that are just ghost features. And so what we might be handing out is something that could cause a little bit of this challenge in the communication space. We really aren't sure yet quite how to relate these things together, and that's going to be, for our social science side of the house, part of our active area of research going forward. What should the relationship between these two things be? Because we don't want to create this any additional confusion. We want these products to be helpful decision aids. So you raise a really good point.
Yeah, I think in addition to that, one of the ways that we're trying to address that is to not, one of the nice things that has been happening that Kim talked about is, bringing broadcasters into the test bed, and not only, National Weather Service forecasters. And I think that's really great. But I think that also making these products available in real-time operations and seeing, like, naturally, how do forecasters see using this, and how do they integrate, the information as they get used to it, is, it's really important, to have that component in terms of what we're doing. And, maybe that means, also that, we would build relationships with other parts of the weather community who would be willing to be partners in looking at this, knowing it's a research tool, and looking at how it might be useful in providing feedback. It wouldn't necessarily only have to be a WFO, for example.
Of course, the other thing I think about, Kim, is where we are, and I think this is true probably nationally, most people cannot find their house on a map, and most of this graphical output is using mapping, right?
It is. So I'm actually curious to know if you folks are familiar with a new technology. I think the next generation of television broadcasting technology, ATSC3, that's coming in the next couple of years. For those who haven't become familiar with it, this may offer the opportunity to address some of those challenges. It basically will turn your television into a little computer where there will be broadcasters who are giving, for example, say a live weather broadcast, but you, James, may offer some supplementary information as a button that's visible at the bottom of the screen. If viewers want to select it, and they can then dig down and get this additional, say, probabilistic information. You might not want to show it on air to everyone, but you might offer it as a separate stream. ATSC3 is a technology that will offer the capability to facilitate drill down. So you can offer sort of one message to everyone, but then a user could be in a particular place and they could be getting automated alerts from their television. Their television could turn on when there's a plume, a fee plume, a probabilistic hazard plume coming their way, and it is something, tornado over 30%, turn on the TV, I want to know. That's something that could be possible with that technology, and that would help for folks who are a little bit less geographically oriented, geographically savvy, which I personally don't think there are, the concern is as strong as some may feel that it is, but for people who that is a challenge, the TV does a lot of the work for them.
Yeah, and our company is heavily involved in that technology, and they promise they're going to fly me up there and get me in the loop, and so I can understand the practical application in weather. But this just, I feel like we're not quite where we need to be right now, and you, all of you on the show that are smarter than me, you can help us figure out how to communicate these risks better. But let me change the subject. So when is phased array radar coming, Pam?
Good question.
Operationally for the world.
Operationally for the world. Well, there are several considerations to be thinking about when we talk about operationalization of phased array radar. And so one of them, of course, is the readiness of the technology. And the system that we used previously was actually technology from a Navy ship that was built in 1970. So we were able to show a lot of utility from that system. However, that system was not state of the art, and it was not dual polarized. And we know that the system's been upgraded to have dual polarization capability. And so what has happened at the National Severe Storms Laboratory is that we've torn down that old system. Okay, so took it down, and we're now building what's called the Advanced Technology Demonstrator. And it was built by MIT Lincoln Laboratories, and it is a phased array radar panel. And one of the challenges with that system is really an engineering one, in which you want to make sure that the vertical and horizontal isolation for the beams, for the dual pole beams, you have to have isolation between those two. And that's one of the challenges with a system like this. And so right now at the building of the system, the engineers are very heavily involved in taking measurements and looking at the feasibility of a flat panel array, for example, versus a cylindrical array. So there are some technical or technological engineering challenges that need to be addressed. And another part of this is also the Weather Service plans. And so they have a program in progress right now where the pedestals are going to be replaced. And so the goal is to extend the life of the current system out to maybe 2030, even a little bit longer than that. And so we have both technological challenges that we still need to handle, as well as fitting within the plans of the National Weather Service.
What Pam is trying to say, I'll be dead by the time it becomes operational. See,
that's exactly what she said, yes.
Brian, the two of us, we'll be at Elmwood Cemetery by then.
Pushing up daisies, and maybe they'll be waving in the wind.
What wavelength, in terms of RF, will it be on the same wavelength as the current NexRad systems, or is this a different wavelength?
Yeah, the plan right now is a similar wavelength, so it'd be an S-band type system.
Right. Okay. Well, I'm excited. The thought of that, just getting that instant information without having to worry about this old-fashioned, parabolic dish spinning around and around and around and around. And there's no moving parts, right?
That's correct. Yep. If you're polarized, if your panel is electronically scanning in the horizontal and vertical, then there's no moving parts.
Wow.
So that's really cool, Pam. Take us back, on the layperson's paper that you have on the web about the about one on forecast uses the Tuscaloosa to Birmingham tornado. Talk about that scenario, how that would evolve under one on forecast as opposed to the warnings that we issued in 2011.
Okay. Yeah, we actually have a study on looking at the performance of warn on forecast on that day, using the low-level updraft helicity as a proxy for strong circulations within those storms. And so what would happen from a warn on forecast perspective is that you would have forecasts, as the storms were first starting to develop, and you have weather radar, data, and there's just starting to take form. That data would be assimilated into the model, and so from that we would get forecasts that would then show the evolution of that storm, in terms of features such as updraft helicity, the intensity of reflectivity, and other variables. And what is that path going to be? What are the areas, that are within that path of the most intense values and things like that. And so I think one might get a sense earlier from these rapid update forecasts of what the expectations could be for that day. So you would have that prior to the very intense development of the storm on the radar, from which then you're attempting to take the precursors that can be seen within that data along with the environmental information to get a warning out. And so this would then extend ahead of time, I think, the forecaster's confidence in what may be unfolding as the event evolves. And which storms are going to be the big storms. And of course, there were a lot of storms that were very intense and important storms on that day. And I believe that it's Nusrat Youssef who has a publication on that. And the model actually did pretty well on most of those storms. So it's not like it only picked up on one or two of them. It did a good job handling, you know, from a proxy perspective, those storms that, you know, were very devastating to that area.
Let me ask a question about updraft helicity. There's some people in the science that think it's greatest thing ever. Some people say, you know, it's overused. It's not worth it. I was trying to scan a paper here that's written by Patrick Marsh and Harold Brooks, Chuck Doswell, and Hitchcock. Did you give us your thoughts on that, Pam? That is a useful tool for those of us in the operational world.
Yes, I think it is. And there have been a number of studies looking at its utility as a mode. So a mode indicator. So, you know, if you're looking at the forecast for a day and, you know, the updraft helicity is, you know, really low, odds are it's not going to be a supercell, for example. There have been some recent studies, I know, that show a pretty good correlation between updraft helicity intensity and hail occurrence in storms. And I know that's something that we're looking at as a predictor for hail size, and it may even be better than some of the more complex algorithms or like models that have been used for hail. And then also as a proxy, there have been a number of papers looking at it as a proxy for potential tornado occurrence. And I think, you know, in all of those areas, it's showing some very strong utility.
I'll say this down here in Dixie Alley, it has performed very well on very active days where all the parameters are in place. Everybody expected a severe weather type event, a big event. I think it's very useful. And again, you know, it's just another tool in the toolbox, as people say, but I think it's a very useful parameter for us. But we've got to take a very quick break, ladies and gentlemen. We've got Tony Rice with his Christmas night astronomy report. We're going to come back with picks of the week and more as WeatherBrains rolls along. So stay with us. Here's Tony.
Looking beyond the atmosphere, here's Tony Rice with your astronomy outlook.
Looking back on 2017, there's one space event that outshines the rest: the solar eclipse visible across North America. The moon completely covered the sun for those in a coast-to-coast path from Salem, Oregon to Charleston, South Carolina. But the big question leading up to it was, would we be able to see anything? Meteorologists became the rock stars in the weeks leading up to the big day. And hopefully, we all learned a little bit about the challenges of forecasting cloud cover in particular, and especially for a 3-minute long event, even the day of. In the end, much of the Northwest had a clear view, with a little bit of haze from wildfires in Idaho presenting some challenges, and the typical summer buildup of cumulus clouds and isolated showers, as expected, was the story in the upper Midwest and Great Lakes region. We also saw some spotty storms in the Tennessee Valley and the Carolinas. This hid the show for much of the partial phase in some areas, but most reported being able to see at least something, especially during totality. In space exploration, the Cassini spacecraft ended its 19-year, 11-month-long mission studying the Saturn system, including the planet, its rings, and moons. We'll be studying the images and data from that mission for decades to come. The OSIRIS-REx mission stopped back by Earth for a gravity assist in 2017 as well, ahead of next year's rendezvous with an asteroid. Some plans, though, never really materialized in 2017. One example is China's intention to launch the Chang'e 5 lunar exploration mission. This is a sample return mission and was supposed to bring back 5 pounds of lunar rocks and soil. That's something that hasn't even been attempted since the 1970s. The latest estimate is now 2019 for this mission, though. 2017 was a busy one on the world's launch pads, and the United States once again led the way, with a 100% success rate on 28 launches throughout the year. SpaceX plans to bring that up to 29, with a launch from the Vandenberg Air Force Base in California planned before year's end. Russia put 19 of 20 into orbit, and China 14 of 16 successfully into orbit. Overall, the world's spacefaring nation successfully launched 79 of 85 times. Speaking of SpaceX, they had a pretty good year too, chalking up a few firsts along the way. They achieved their first successful landing on a drone ship, first launch and landing of a recycled rocket first stage, and the first reuse of a Dragon capsule. Next on WeatherBrains, I'll have a look ahead for the don't miss events for 2018 in space. But until then, the Moon and bright star Aldebaran offer a nice finale for this year. Mark your calendars for December 30th at 6:10 p.m. Eastern or 5:10 p.m. Central. This really won't be visible much farther west than there. But the 93% illuminated moon will pass in front of or occult that bright star Aldebaran. It's really pretty cool to see. The star will reemerge on the right side of the moon about 45 minutes later. Now, you might be able to see this with your naked eye, but binoculars will really help you see that star move behind the dark limb of the moon. That's your astronomy wrap-up for 2017. Follow me on RTP Hokey for more spacey stuff like this.
So we're not going to do a weather roundup because we're recording this 5 days in advance, and we're not that good. So for some of you, it's probably cold. Some of you, it's probably mild, and Kevin's cranky. So that's pretty much the lot. So
Hey, it's Christmas time.
well, it is Christmas. We should be happy and joyous. You know, I'll never.
Do you have the? We did a Christmas thing. The 12 days of WeatherBrains. Do you have that?
Did we?
Years
No.
ago.
I need to pull.
Matthew and I recorded that.
Oh, but I should pull that up. I don't have it at my fingertips here. But no, when I think of Christmas Day in the weather office, I think 3 years ago we had a severe weather day, and I had to cut off an NBA basketball game. It was Cleveland and Golden State. So this was LeBron James and Steph Curry. And we covered about maybe 40 minutes of the game. The first email I got, Brian, I think you know my story. You know what it said. You should have been aborted by a coat hanger.
Wow.
So welcome to my world. Joy to the world. Peace on earth. So it's been quiet here. So let's do picks of the week here. Aubrey hopefully will be in for our New Year's show next week for email, but we're going to go right to picks of the week. So Bill Murray, you're in St. Louis, Missouri tonight. What's your pick of the week?
Well, I've had a great time here. We're getting ready for the NWA Weather Ready Fest that'll be here August 25th, and so we've been meeting with a whole crew of people, including your old friend Mike Murphy today. And James, he gave me some of his Murph's Magic Mix for my.
Oh man, let me tell you what.
Next
time you cook out, use that stuff, and it is awesome.
I thought it was like butt paste or something, but it's for the barbecue. So
Wow. That's a show title right there.
Yeah, no kidding. Sounds illegal.
But it's been a great visit to St. Louis, and I'll be with the Weather Service tomorrow and the emergency manager, and so it's going to be an exciting time. If you want to help out with the Weather Ready Fest, we would love to have your assistance. We're putting a great lineup together right now, and that'll be in late August as part of the NWA annual meeting that'll be here in St. Louis. So my pick of the week comes through Dr. Pat Market at Mizzou. He told me about the True or False Weather Fest or Film Festival that's in Columbia in early March, and I talked to the organizers there, and they're using a really unique weather, a play on words, visual theme relating to the weather. So thought I'd give them a little shout out tonight because film festivals are one of my favorite things. And that's my pick of the week, James.
Awesome. Kevin, what's your pick of the week?
Sorry, I got nothing.
what?
I'm sorry.
I can't recall the
Well,
last time
you
I had
could-
to blow this.
I said I was sorry.
Well, we gave out the secret address for all the information that Pam is telling, and so we made everybody swear a pledge of proper use before they could have the link. Yeah.
I'll take those then.
Okay. All right, Brian, you've been quiet tonight. Did Santa Claus not come see you? What's going on there?
Santa Claus hasn't come yet.
Well,
He doesn't come
now he's-
until next
Now he's
week.
gone and destroyed the illusion.
Yeah, I know.
Now he's blowing our cover
You're
here.
supposed to be out.
That's right. Oh, gosh, yes.
See, we never
well,
saw Santa Claus and Brian in the same place.
Since a lot of people aren't getting a white Christmas, I ran across the story that actually the MIC at Fort Worth, who used to work here in Birmingham, Tom Bradshaw. He posted a link to a Fort Worth write-up about the 1929 Texas snowstorm, and I found it fascinating, so I think since it's appropriate to December, I'll use that as my pick of the week.
Awesome. Good deal. And all these links will be up on the website, weatherbrains.com. My pick, for those that don't know him, it's Dr. Judah Cohen, and he is with this group called Atmospheric and Environmental Research, and he writes some notes and thoughts and forecasts based on Arctic oscillation, snow cover, polar vortex analysis. Very interesting, especially in the winter season. And if you follow him on Twitter, it's just some very interesting stuff. So that's my pick of the week. All right, Kim. And by the way, Pam, we're stalling. You'll go last. So you can come up with something for a pick of the week. Kim, go. What you got for us?
Sure. So after we had Maureen McCann on last week, she mentioned an AMS board that I didn't even know existed. And I thought that I was pretty familiar with the bureaucracy. But there's this wonderful little board that's, I think, a board commission on best practices. And they have just published this year their first statement. So I have shared a statement of best practices for publicly sharing weather information via social media. Is this a best practices document you guys are familiar with?
Kevin, are you in on this? Did you write that policy?
Oh, she put it in the chat a while ago, and I was very excited to see it. I haven't looked over it yet, but I think that's going to be great reading.
Okay.
Yeah, it's really great. It has a lot of, I think I've read through it, and it is a very wonderful, well-balanced document. Also brings up communicating uncertainty as part of being transparent in communicating the forecast. And something relevant to our conversation tonight, a good forecast will place possibilities within the reality of the limits of the science and not be perceived by peers as being an exaggeration. Always a good pointer.
Oh boy!
I can think of a few people. That need to read that.
Yeah.
Don't
send it to all your close
It's Christmas.
friends.
It's Christmas. We're not going to call out any names here.
I didn't say names. I just said a few people.
In fact, look, I think everybody, well, at least I have been guilty. Everybody here's probably been guilty of some boneheaded tweet or, post or something over the years. So we're all guilty. All right, Pam, we've stalled long enough. Do you have anything remarkably interesting for us that you want to share as a pick of the week?
Well, earlier today, I gave a webinar to the National Weather Association. And so I will give a call out to that webinar. I believe is available on YouTube. And so if anyone listening to this is interested in seeing some slides and like real examples of the forecast that I'm talking about, there are several examples within that webinar. So, take a look for that on YouTube.
Awesome. Those are great webinars, by the way. I didn't get a chance to see it, but I will put that on my things to do list while I'm off next week. So anyway, thank you, Pam, for being on the show, and thanks for all your work. It is greatly appreciated. We're going to wrap this thing up because I have to go change and do some television. And again, let's see, Bill Murray, next week we will have Greg Carbon on, right, for the annual year ender. Correct me if I'm wrong.
That's right. We'll be revealing his number 10 on the list of the biggest weather events of 2017. So we're really excited about that.
All right, and Greg does this talk at conferences around the country, but he never has the number 10, so he will unveil that. And if you've not heard the list, he'll have that on the show next week. And we're on a regular release schedule. This show, you'll probably listening to this on Tuesday the 26th, and you'll be hearing the New Year's Day show. It'll be out in the podcast version early Tuesday on January the 2nd. So anything else? Are we done here, Kevin? Anything on your mind you want to share? Any gripes? Any other crankiness you want to open up? I got 2 minutes here.
No, there's always gripes, but it's Christmas, so we'll hold those.
Yeah, we'll hold those until next week. So, here is the deal. WeatherBrains is typically produced Monday nights at 9:30 Eastern, 8:30 Central, and when we do that, most people watch at live.bigbrainsmedia.com. But we know that most of you listen to the podcast version, and we are thankful for that. If you want to get in touch with us, the email address, it's email@weatherbrains.com, and Aubrey is our email official. She will be back on the show next week, and we'll read some of those. Our social media accounts on the website, weatherbrains.com, and the show notes, all the links, the things we talk about, it's always there. So on behalf of the entire WeatherBrains crew, I'm James Spann. Thanks for listening. Hope you had a Merry Christmas, and God bless. Hey, Pam, thank you. I
Thank
appreciate
you so
your
much.
work.
Yeah, thank you
Ma'am.
for the opportunity. This was a really fun way to spend my evening, so I appreciate it.
You almost sounded sincere. Almost.
You're very
Yeah,
sweet.
I'm always sincere if I say something
Right.
like that. Trust me.
We need to
Okay,
get
thank-
some hobbies.
Yeah. But Pam, thanks so much.
Thanks.
Thank you all. Again, we'll see you all tomorrow for the New Year's show. Thank you all. Bye-bye.
Okay,
Bye.
bye.
Good one.
Bye.